Hello, this Eagle tutorial is going to show you basically how to use a part that you found that you'd like to incorporate into a project and perhaps eventually a circuit board. Today we're going to cover a VGA connector, but this could be any kind of connector, any weird shaped resistor, inductor, chip, whatever. So anyway, according to the description here, this is a DE15 or a D sub 15. And I've already found one of these female connectors on DigiKey for about $2, and I've opened up a link to its data sheet here. So what I'm going to do, I'm not going to cover the whole process of creating and importing a new library in Eagle, but I have an empty schematic and empty board open, and I'm going to open up my personal parts library, and we'll get started. Now first we're going to create the package, and then we'll create the symbol, and then the device. You can do the symbol first and the package second, doesn't matter, but the device is going to come third because it's a combination of both the package, which is used in the board layout, and the symbol, which is used in the schematic. So the package is going to be the connector type itself, which is DE15, and that could cover something other than a VGA connector if we so want. So I'll create this new package, and then in the data sheet, usually you want to start by looking for the recommended PC board layout. Also, it's good to note if it says what the dimensions are. This one is in millimeters. Oftentimes you'll see both inches and millimeters. One will be outside like this, and then perhaps brackets with another number inside. So it could be inches and then in brackets millimeters, or millimeters then in brackets inches. And in this case there's only millimeters, and sometimes it'll be inches and it won't even tell you. So it's kind of all relative. If it says 25, it's probably millimeters. Anyway, we're going to start with all the holes. So these, which would be kind of our pads, our actual electrical connections, and then these two other holes, which as you can see on the picture, are kind of mounting posts for stabilization. So I'm going to start with the electrical connections. As you can see, this 1 indicates pin number 1, and then there's 14 other pins. Now if we look at our pin out on Wikipedia or wherever else, it's kind of hard to see, but this is pin 1, 2, 3, 4, 5, 6, 7, 8, blah blah blah, 11, 12, 13. So we can make the assumption that since we know pin 1 is here, this is 2, 3, 4, 5, and then 6, 7, 11, 12, etc. Okay? This information is pointing at one of our pins, and it says 15 places. So all 15 pins share this same information. The hole size is going to be 1.19 millimeter. So we'll initialize in Eagle the pad that we're going to use. This is a through-hole component, so this has a drill in it. This would be for SMD pads if you have a surface mount device. My grid is in inches, so I'll switch that over to millimeters. And my drill will be 1.19. And then for the surrounding area, and I'll make it round as well. For the surrounding area, you can use auto. I like to force it to a specific number. That's a couple, whatever is larger, 0.3 larger than this. So let's try 1.4. Actually, that's pretty small. Let's go 1.85. And that looks pretty good. We could even go up a little bit more. 1.9. That looks good. Okay. This shows us that the space between this row of pins is 2.29. So in Eagle, I'm going to set my grid snap to 2.29. Yes, 2.29. What that'll allow us to do is we can just, not worry about the positioning so much. So 1, 2, 3, 4, 5. So I'll create, and actually the copper itself is pretty close to each other. So I'm going to remove the first one and set that maybe closer to 1.75. Okay, so 1, 2, 3, 4, 5. Okay, that's pretty good. Now we look for the second row. This is going to be 2.54 up from the other row. So what I'm going to do, 2.54, I'm going to select everything, set my grid to 2.54, and then move it down. According to this, which lines this center point up with this center point, it's a 1.14. Just for fun, alright, 2.29. 2.29. Let's slide everything over 1, 2, 3, 4, so that we're looking at this center point, which would be here, which is 1.14 from that one. 1.14. Then select everything and drag over by one click. And then we'll place our second row of pins. I'll set my spacing back to 2.29 because it's the same there. 2.29. 1, 2, 3, 4, 5. Okay? And according to this, the space to the next row is also 2.54. 2.54. And we need to shift back by 1.14. Then I'll set my snap for placing pads back to 2.29. And I'll set the last row. There, that's it. We have all of our holes. So, well, not all of our holes, we still have these. So, let's see here. According to this, the center point of this pad is 7.04 from this stand post. So, 1.14, I'll shift back. 1.14, move everything back there. And I remember that it's 2.54 from the middle row, or between rows rather. So now my center point 0, 0 is back here. So I'll shift over by 7.04. Now, according to this, there's two places. Yes, there's two holes. And it's 3.18 in diameter. And this is a hole. We don't really have to solder to it. So instead of using a pad, I'll use a hole. And that hole size was 3.18. I'll just create one right in the middle there. And according to this, we're 24.99 from the other one. So 24.99. And I don't actually have to drag everything over, because if you look, this one is at 0, 0. And if you look here, when I move with that one, it says negative 2499 and 0. So that means that these are exactly 24.99 spaced from each other. Cool. Now, I know I'm here. I know the distance to this one. I can tell that these are equal spaces from the sides. So I'll actually take 24.99 and divide it by 2. And hit Control C to copy that. And I'll set my grid to that. Select everything. And then, oops, wrong direction. I've actually centered everything horizontally anyway. But I don't want to leave it at just that, because if I throw this on my circuit board, I'll probably be confused. I want to know that the female connector is going to stick out here, and that somewhere around here is going to be the needs to be the edge of my PCB, and also I need to know how big the rest of it is so I don't place components there. So I'm going to look elsewhere for that information. This side picture looks appropriate. According to this, let's see here. What is the easiest way to find that? I think in order to find the entire length from this, which as you can see would be the same as this, which it says should be the PCB edge. So from here to the back, which would correlate with this dotted line, I don't see a single number anywhere. So we're going to have to add these up. So let's do that. But first, actually, that might not even be necessary yet, because we need to know where to position it from. So we zoom in a bit more. Not quite that much. We know that we're in this center row of pins right now. That's our current origin. And yes, indeed, from this pin to this pin, it's 2.54. However, this arrow is pointing at the center pin and pointing at the back of everything. And it says 4.57. So from the center pin to the back, it's 4.57. 4.57. So I'll slide everything down by that much, and we know that this is where that dotted line would be here. Okay, cool. Now we need to know how wide it is. So we'll look at a different view. Probably this one. In fact, it looks like that right there. From this edge to this edge is 30.8. So it's 30.8 wide. However, I'm still located on the center point. So I'm going to take 30.8 and divide that by 2, 15.4, and set my grid to that. So this is negative 15.4, and this is positive 15.4, giving us a total of 30.8. So I'm going to create a line, and by default it's already selected. We're going to use T-place, top placement, and that's what you should do your outlines. So from negative 15.4 to positive 15.4, and then hit escape. That covers the back edge of our connector. So now I need to know in total how long it is, so we can move to the other side, or actually to the PCB edge. So I know that we are 4.57 to the middle row, picked up, and then from the middle pin we're 2.54 from the next row of pins, next row of pins, and then from that row we are 8.89 to the edge of the connector. 8.89. 8.89. It's like that. And we know that this is the same length because it's a box shape up until the actual connector itself. It's all box shape. So I could just copy that. I can't copy that yet. Actually, we need to figure out in total how long the whole connector is. And that's probably something worth writing down. So from this edge to the middle pin is 4.57. From the middle pin to the next row is 2.54. From that row to the edge is 8.89. So it's 16 millimeters. Yeah, sure enough. our other edge is right on the 16 mark. Now I can copy it. Okay, that's cool. Make a notepad. Keep some of these notes. Now we need to figure out the width. Oh, I'm sorry, we already know it. It's 30.8. So I'll take that 30.8 divided by 2, set my grid to that, and then move everything over so we're right there. Then I'll set my snap back to 16 so that I can draw a line exactly from here to the other edge. And now I'll set my snap to the full width of 30.8 so I can copy this edge from this side to the other side. And we're actually almost done, but I'm going to go one step further and actually show the connector coming out of the end. And they say from the very end of the connector to the very back of the connector is 22. So that would be plug length equals 22 minus 16, which is 8. Is it not? Sorry, it's 6. Yeah, 6. Okay, so let me recenter by doing 30.8 divided by 2. And we're already here on that piece. So I know that the plug length is 6, but how wide is the plug? Plug is 16.3 wide. So 16.3 divided by 2. Shift over by that much. And now we know that the plug length is 6, so I'll put in 6. And this time I'm going to, instead of using placement, I'm going to use T-docu. It's kind of the lesser half of T-place. Kind of just for extra details that are not really part of the placement, but they help to signify things. This is going to be sticking off of the edge of the board, so we don't really care about it, but it'll be helpful to me so I know that this is the side that belongs on the PCB edge. Otherwise, I might put my connector on backwards. So let me place that line, and then we know our connector is 16.3 wide. So I will just copy that one over to there. And then I know that it's 6 long, so let's move up by 6. And then, what's the width again? 16.3. Now I'll finish the line from there to the other side. Okay, so we'll move back by 6. And we'll move back by half of the connector width. And then the length of the whole connector was, 16. So I'll move by half that, by 8. So now I am centered in the whole part is centered around the center of the primary thing. Okay, so anyway, I do recall that this was pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Especially because I placed them out of order, it's good to go back and rename them with just simple pin numbers instead of the P, dollar sign, all that stuff. And to remember to do that, so that it would suck if we finished this part, built a device, and had never changed the pins that were out of order. So So anyway, we're done. Well, actually, almost done. Last thing I'm going to do is add a angle bracket name and set that on layer T names. I'll also turn my snap down a bit because we don't need that anymore. And maybe even turn the size up a little scooch for this. I'll just throw it there. I do the same angle bracket or whatever value and set that on T values. So those are special. The actual name that we give our part in the schematic will show up here, and the value will be, I believe, DE15, or actually maybe it'll be the device name or something like that. So anyway, now we'll save that. There's some other interesting things we could do if we were making a homebrew board and it was going to be one-sided or whatever, or if we wanted to restrict vias, then we could do a fill rectangle. So let's say I didn't want any vias underneath my connector because I'm doing it at home and I don't want to have those little solder bumps under the connector. Then we would do a V restrict for via restrict, and I can just draw a box around wherever I don't want a via, etc. Or you could do T restrict or B restrict to restrict top or bottom copper. But I'm going to professionally make this board, so I don't care. Vias are nice, especially when they're plated. Anyway, we're done with this, so let's go ahead and make the symbol real fast. So I click the symbol button, and I'm going to call this one actually a VGA connector. Yes, great. Yeah, make sure your grid is set to 0.1 inch, at least by default, unless you changed your schematic grid. I like to use short connectors. Long is usually way too long, and point has no tail at all, but short is my favorite. So anyway, well, we know that we're going to have 15 pins, but actually, are we really going to? Are we going to use all these? Yeah, we'll use all these. Okay, so let me leave that up over there. Okay, 1, 2, 3. Well, I can just keep making because it keeps count for me. And we don't care which one is pin 1 or pin whatever at this point. So let's just start from the top down. Red, green, blue, ID2 and res, ground, red, return, green, return, blue, return, key and whatever, another ground. Oh, ground already exists, so I'll just do ground 2, ID0 and res, ID1 SDA, HSync, VSync, ID3 and SCL. Okay, now I'll probably pair these up a little bit more logically. So, red and red return. Let's do. Let's group them like that. So I'll have red, red return, green, green return, blue, blue return. I'll put all my grounds underneath. Key and power is really more like power, so we'll put that up there just in case we want it for something. These are kind of out of order, so let's get ID0, ID1, ID3, and then under that we'll have HSync and VSync. If I select these, use the move tool, and then hold control, right click, we can move these around. If I just single click the mouse wheel, I can mirror them. Let's try to scrunch these up as nicely as we can without making them look messy. Those are pretty close. I like that. So now I'll do a line, a symbol here around the edge of everything. So it looks like those pins are, connected into our device. I'll grab everything. This is more important with symbols, but it's good to do with everything to center your part over the origin. And likewise with the package, I'll do a name and value right there. That looks good. We're basically done. The only thing left to do is to create our our device. So we'll go ahead and click that. I'll also call this VGA connector. Yes. Over here, we need to drop in our schematic symbol. So we'll click this button for add a part, and then we'll browse for our VGA connector. And then making sure that our snap is 0.1. I'll just add it right back into the center. Over here we'll click new to add a package, and we'll select the DE15 that we made. Now we need to connect them. So we'll go ahead and click connect. So pin 1 on the package is going to be red on our symbol. So we select both of those and press connect. And over here on the connection it shows pad 1 is connected to red. Now pad is going to keep going down just a list of already sorted numbers. So all I need to do is just double click things over here. So 2 is green, 3 is blue, 4 is ID2 in res, 5 is ground, 6 is red return, 7 is green return, 8 is blue return, 9 is key power, ground, ID 0, ID 1, H sync, vertical sync, ID 3. And I like to sort by pad and run through and double check everything because it also would suck to make a mistake here. Anyway, click OK. That turns into a little check mark and we are done. Save. Go back to your schematic. Click Add a Part. Browse for your library and find our VGA connector, which we can drop in. It has, let me show my pins here. It has nicely everything named. Let's add just a, I don't know. Let's add, let's say somehow we're driving all this with a PIC microcontroller. So we'll just make some connections here. I don't know, red and green. Oops, green. And blue, and we'll say that the returns and grounds are all going to connect to whatever ground is going to be here. And then, yeah, let's say we're going to support, those ID numbers and stuff. Oh yeah, H-sync and V-sync, those are crucial. Again, I don't know if I'm hooking this up properly. Probably not. So this is just an example. So anyway, you can use your actual pin names and your actual pin out names, which is nice for schematic mode. And then when you switch over to your board design, then we have everything already air wired as they should be. And I know that that's my plug because I drew it in there. So we'll put that right down to the PCB edge. Stick our chip there. Maybe I'll slide everything over a bit. And bring that down, bring that down. No, auto route. Alright. Awesome. Oops. Well, anyway, that just about covers it. This chip, for example, I put that in too. I got all sorts of other stuff in here. So you can do it with that. Here's a fuse, for example. And let's see, I've also got, here's a custom plug, which is labeled for LCD things. But over in here, it's just a regular, some kind of Molex jack or whatever. So let's see, some other switches. I think I got some dip switches in here. Yeah, here's a DB9. This is a good one, especially for microcontroller projects. We've got our RxD and stuff already labeled. I drew a nice little picture. And looks pretty similar to the other one.